Welcome to lecture 6.4. So we're looking at inverse functions again, and we're going to look at the main three: sine, cosine, and tangent. And as a reminder, these are the domains for the values, and then the ranges. And the domain, those are the allowable input values, and then the range are technically the output values. So let's go ahead and evaluate some of these inverses. So for sine inverse of a half, how would we solve this? Well, if you recall, we could go ahead and set this equal to some value. So let's go ahead and say maybe theta. And then, using the inverse rule, we know that sine of theta will equal a half. By just changing this to the regular sine, we've taken the inverse. So now the question is, what value has a y, or what value on the unit circle, so somewhere over here, which one has a y value of a half? And the value that has a y value of a half is pi over 6. So we have that theta equals pi over 6, which would be radians, or how about degrees? That is 30 degrees. And once again, you need to be careful what your calculator is set on, either radians or degrees, because that can definitely slightly screw with your answer if you're putting in the wrong setting. So now let's go ahead and evaluate cosine inverse. So once again, we'll do the same method. Set it equal to theta, then go ahead and do the regular. So cosine of theta must equal root 2 over 2, since these two guys are inverses of each other. And then we ask ourselves, when is cosine root 2 over 2? Well, that is up here at pi over 2. So theta must equal pi over 4. Theta equals pi over 4, or what is that in degrees? That is 45 degrees, half of 90. And then tangent inverse. Go ahead, try this one by yourself and check in with me in a second. Okay, same plan. Let's set this equal to theta. Then tangent of theta equals the square root of 3. So when does tangent equal root 3? Well, that would have to be root 3 over 2 all over a half in order to get those canceled and left with root 3. Which means y should equal root 3 over 2 and x should equal half. And that happens at pi over 3. So theta equals pi over 3, or 60 degrees. Alright, let's take a look at example 2. Evaluate sine inverse of 0.8. So if I were to set this equal to theta, I would have sine of theta equals 0.8, but I don't know how to solve for that using the unit circle. So since I can't figure this out using the unit circle, we'll go ahead and use a calculator. And once again, you might say, well, when can I use a calculator and when do I need to evaluate by hand? On your exam, there will be a section labeled no calculator, so you should not be using your calculator for any of your final answers. It should all just be done with the unit circle, and then there will be a section where you're allowed to use the calculator. So plugging this into the calculator, remember it's going to be second, hit second, and then sine, and that'll equal 53.13 if you are set in degrees. So check your settings. Let me go ahead and do the approximate. If your settings are in radians, you'll get about 0.927. Once again, why did we use the calculator? Because we could not find that using the regular unit circle. Now the same thing's going to happen here. If I was to set this equal to theta, and then do cosine of theta equals 0.3, I would not know how to find that on the unit circle. So we're not going to use that method. Let's go ahead and use the calculator. And plugging that in, I'll get about 72.54 degrees, if I do degrees, and about 1.266 if I had my calculator set in radians. Now go ahead and try to do tangent inverse by yourself. That one, once again, we are going to use a calculator for that one, because I could not find that using the unit circle. So that'll come out to approximately 75.96 degrees. Once again, that is in the setting of degrees. And then if I do the setting for radians, that'll be 1.32 radians. Alright, let's go ahead and take a look at some examples. So example 3, find the angle and write in degrees. Okay, so this is interesting. So we're going to work with the angle and then we have to answer in degrees. What angle am I trying to find? Well, I'm trying to find x for this problem. So let's think back to the last the last section we did. When we have an angle, we have to figure out which of the legs are we given. And it looks like we're given the hypotenuse. We don't have the opposite value, so that one is not given. But we have the adjacent. So which trig function, has adjacent and hypotenuse in it? And that would be cosine. Cosine has adjacent and hypotenuse values. Let's go ahead and use cosine to solve. So we know that cosine of our x value, x degrees, is going to equal adjacent over hypotenuse. So adjacent over hypotenuse. Okay, solving for x. We got to get x outside of cosine. So to get it outside of cosine, let's go ahead and take the inverse of both sides. Once again, please show the step when you take the inverse. That is something I will be grading for. Oh, wrong color there. Okay, so then those cancel out. Oops, cosine. Yes, okay, those cancel out the cosines. So we're just left with x equals cosine inverse of 109 out of 134. Plugging that into the calculator, because we could not find that in the unit circle. In the calculator, x is going to be approximately 35.37 degrees. Okay. So we found the angle in degrees. Now let's look at the next triangle. Where is the angle we're trying to find? It's right here, alpha. So let's figure out which legs we're given. We are not given the hypotenuse. We are given the opposite leg and the adjacent leg. So which trig function uses opposite and adjacent? That would be tangent. So we're going to go ahead and use tangent to solve. So tangent of, and this time we have alpha. So once again, if you are given a specific variable, please use the variable. If you're not given a variable and you have the choice to make up your own, feel free to make it up, but make sure to write a let statement. What do I mean? If you made up a variable, you would need to say let alpha equal, and then whatever it is you're bringing in. Okay. Alright, so we have tangent of alpha is going to equal opposite over adjacent, which will be 6.37 divided by 1, 5.3. Ooh, and notice the units are inches, so you have to be careful to answer in inches. Okay, so, well, let's see, how would we solve that? Alpha is inside the tangent, so to get it outside, we're going to take the inverse of both sides. So tangent inverse on both sides. Once again, please show this step. That is something I will be grading for. Okay, then tangents cancel, and we're left with alpha equals tangent inverse of 6.37 all over 1, 5.3. Plugging that into our calculator, alpha is approximately 22.60 degree. And would we use inches here in our answer? And the answer is no. The degrees are not in inches. They're just degrees. Alright, so hopefully that wasn't too bad. Once again, feel free to email me for an office hour. Example 4. Find all angles between 0 and 360 satisfying cosine of theta equals 0.4. Alright, so this is going to be a calculator problem. I'll go ahead and walk you through this on here. So, for the calculator, what you're going to do is go to your graphing section. Please make sure that x is in degrees. And then you're going to pick your first y value. y1 should equal, and we're going to set that equal to cosine. So y1 should equal cosine of theta. Next, you're going to input another function, y2. That function you're going to input as 0.4. And then you're going to hit graph. So your graph should come out to something that looks like your cosine function, and then the line y equals 0.4. And now, in one period of 2 pi, we're looking to see the values that satisfy that restriction. So there are going to be 2 of them, because it's going to intersect twice. So how do we find the intersections? So we need to find the intersections. So to find the intersections, here are the instructions on your calculator, and I will upload a video on using the calculator for this. So you're going to go second, and then you're going to hit trace. After that, hit intersect. After that, you're going to hit first store, and then hit enter. You're going to hit second curve. Find that, hit enter. And then after that, it's going to say, should I guess? And you're going to say, yes, guess the values. So you're going to hit enter. And then you'll get 2 values that it should guess. So cosine will give you 2 values. So we'll get theta is approximately 66.42 degrees, as well as theta is approximately 293.57 degrees. And once again, I will be uploading a video on how to do this on the calculator. So if you needed more of a visual, go ahead and wait till I upload that video with the calculator for example 4. Now example 5. Find the exact value of cosine sine inverse of 3/4. Okay, this one's kind of interesting. Well, let's go ahead and focus on the value on the inside because we can't do any cancellation right now. Let's go ahead and focus on sine inverse of 3/4. Well, we know how to solve this. We'll go ahead and set that equal to theta. So then we're looking at sine of theta, if we translate, equals 3/4. So once again, we switch from the inverse to the regular one by using the rules of inverses. And then let's see. This translates into what kind of a triangle? Let's focus on what kind of a triangle this is. So sine of theta, and theta is right there. Now sine, if I look at SOHCAHTOA, sine is opposite over hypotenuse, right? So the opposite angle is going to be 3. So not opposite angle, the opposite leg. And then the hypotenuse is going to be 4. So now we have to find out the other angle for this triangle. Let's go ahead and use the Pythagorean Theorem. So we know that 3 squared plus whatever value that is, a squared equals 4 squared. So solving, we'll get a squared equals, let me go ahead and clean that up a little bit. A squared is going to equal 16 minus 9, which means that a is going to equal plus or minus the square root of 7. Notice I did some steps right there. I did the subtraction and then I square rooted both sides. We're going to take the positive. Alright, so a is the square root of 7. So now let's go ahead, this was all our side work. Let's get back to the original problem. So cosine of sine inverse 3/4. Well, I know that I said sine inverse of 3/4 equals theta, right? I said that. So we'll rewrite this. This is cosine of theta. We're using a substitution. Well then what is cosine of theta? Recall, cosine is SOHCAHTOA. Cosine is adjacent over hypotenuse. So, what are the adjacent and hypotenuse values? Adjacent over hypotenuse. And there we have root 7 over 4. So this one was kind of sneaky. We had to use sort of a substitution. You didn't have to, but this was a way to solve it. You could use the substitution because we couldn't do that cancellation with the inverse. Now let's look at example 6. a 30-foot ladder leans against a building. Let's go ahead and draw an image here. So I got like a building, right? Some sort of a brick wall section going on here. And a ladder is leaning against it. And then here's the ground, right? And it's 30 feet. So this thing is 30 feet. If the base of the ladder is 11 feet from the building, so it's 11 feet from the building, find the angle formed by the ladder and the building. So we want to find this angle. So notice, I have indicated on my diagram what alpha indicates. So you don't have to write a let statement if you label your diagram correctly. Okay, so if you use alpha on the diagram, you don't need to write a let statement. But let's go ahead and try to solve this. So once again, I'm looking at a triangle with an unknown angle, and some of the legs have values attached to them, which means I'm thinking of SOHCAHTOA. Once again, why am I thinking of SOHCAHTOA? Because I have a triangle with some angle that's not known, and then two of the leg values that are known. But what leg values are known? Let's see, this is the hypotenuse, that is known, and then we have the adjacent value is known. So which trig function uses adjacent and hypotenuse? Ooh, cosine. Okay, so let's go ahead and use cosine. So we're going to do cosine of, well, we don't know the angle, so cosine of alpha is going to equal adjacent over hypotenuse. Let's see, to solve, well, we need to get alpha outside of the cosine, so let's use the inverse property. So cosine inverse, and what do we have? Cosine of alpha and 11 over 30. The cosine and the cosine inverse cancel. And then all we have is alpha equals cosine inverse of 11 over 30. And plugging that into our calculator, we'll get that alpha is approximately 1.195. And this answer is in radians. If you went ahead and got your answer in degrees, alpha would be approximately 68.49 degrees. It doesn't say whether to answer in radians or degrees, so that would be up to you unless I state otherwise. This is degrees. Okay, so that is it for 6.4. This is a small geometry review that you can go ahead and use for the practice problem if you would like to take a look at the practice problems. Alrighty, other than that, that is it for 6.4. Please email me if you have any questions.